Okay, wait. Okay, start recording already. Okay, so that means just I'm sharing my I thought I share my screen. Then I'm talking about the test. Okay, doesn't matter. Okay, but you take note, submit by 6:45 today. Okay, so can you see it now?
Yes, Miss, can see.
Okay, thank you very much. So this question is come from here. So the previous slides we have gone through on how to express the following complex numbers, which are in the Cartesian form into polar form, and we have discussed quite a numbers of questions in tutorial. Okay, we have gone through the calculation. Okay, so now is in reverse. Okay, so how we actually express the polar form into the Cartesian form. Okay, polar form into Cartesian form. So this is a question. Okay, so for your recap, okay, polar form which is given as r angle theta. Okay, and there's a principal value we practice on the theta. Okay, so r is actually a square root of x squared plus y squared. Okay, so that's how we get the r. And then the theta is actually arctangent of y over x. Okay, so the x and y, which is referring to the complex numbers in the form of x plus yj. Okay, and then for the theta, which is arctangent of y over x, right? Okay, then your theta is actually we practice a principal value, which is from negative pi to pi. Okay, so that means when we express the angle, the argument for the first and second quadrant, then we will express it as a positive angle. Okay, that means anti-clockwise. Okay, and always measure from the positive of the x-axis. Okay, then if let's say we would like to express the angle for the second and for the third and fourth quadrant, then we are going to express the angle as a negative angle. Okay, so this is a principal value. Okay, now let's move on to the questions A and B here. So A, you have 4 angle 30 degree. Okay, so this is in the polar form and you need to express it into the Cartesian form. Okay, so for your recap, right, when the Cartesian form, right, okay, for polar form, we can write it as a r cos theta plus r sine theta j, right? Which we can abbreviate it as a r angle theta, okay? R angle theta, right? So if you want to express it in the a plus jb form, then you need to know what is the r, what is the theta. So for this case, the r is a 4, then the theta must be 30 degree. So this one will be much more easier. So 4 angle 30 degree, when I write it in the Cartesian form, so the real part will be r cos theta. So that means this is the x, then this is the yj, right? Okay, so the x is r cos theta. So by looking at here, so which is 4 cos 30 degree plus r sine theta, which is 4 sine 30 degree, then j. Okay, so r cos theta plus r sine theta j. Okay, then we just proceed for calculation. So this one is easy, right? Okay, so let's calculate 4 cos 30. Okay, what is the cos 30? So it's actually 0.866 something times 4. So you get 3.464. Okay, then next one, sine 30 times 4. So which is 2j. Okay, so that's how you write the answer in the Cartesian form, a plus jb. Okay, clear, right? Okay, for significance figures. Okay, now part B. Okay, so part B is a 7 angle negative 145. Okay, so it's also very simple. Identify what is a R, what is a theta. So the R is a 7, then the theta is negative 145. Okay, then you just continue to calculate your answer as a 7 cos negative 145 plus 7 sine negative 145 J. Okay, then let's calculate for the answer.
So Miss, for the reverse method, you can put in the negative the sign.
Yes, correct. Okay, so because now when you find the cos negative 145, right? Okay, so it's actually negative 145 is actually in the third quadrant. Okay, so when you're using calculator third quadrant, right? Okay, then when you look at here, okay, all science teacher are crazy. Okay, so when come to cos, right? Cos will be negative in third quadrant. Okay, so sine will be negative as well in the fourth quadrant. Okay, so when you're using calculator to calculate it, your calculator will will give you the negative value. So it's a correct answer. So when come to convert it into Cartesian form, you have no worry. You can just directly plug in the value. Okay. Okay, then sine negative 145 times 7. So minus 4.015 J. For significance figures, right? Okay, negative 4.015 J. Okay, so can you see? Okay, when come to the third quadrant, when the value is in the third quadrant, okay, so for third quadrant, right, X and Y is negative. X negative, Y also negative. And then the values you found is actually giving you the right sign. Okay, so because when you try to calculate this in your calculator, it's actually give you the negative value. So which is a correct one. Okay, so is that clear?
Yes, Miss.
Yeah, Miss.
Okay, so just use the formula. Okay, just use this form. Okay, okay, now, so this one is much more easier. Then we continue. Okay, so actually the slide here, they show you two methods. Okay, first one using the basic angle. Okay, then the other one is directly plug in the value. So then I will strongly recommend you to use this method. The one that I show you just now is much more easier. Let the calculator give you the sign, okay? The right sign. And there's no error, it is a correct one, okay? Okay, then next one is a exponential form for the complex numbers. Okay, so this is the exponential form of a complex number. Okay, Rej theta. Okay, since it's involved an E, so that's why we call it as an exponential form. And when come to exponential form, please take note, the theta here must be in radian. So this one you have to keep on reminding yourself, okay? So must be in radian, okay? Then the R, as usual, is square root of x squared plus y squared. So this one is as usual, okay? The referring to the modulus, okay? X squared plus y squared, square root of x squared plus y squared. But your theta must be in radian. Okay, take note about that. Okay, now let's look at the first one. Okay, how we actually write this into the rectangular form. Okay, hold on. Okay, here they show you how to write it in the Cartesian form. Okay, let me show you how you express it in the exponential form. Okay, so I just take one example. Okay, so let's say, just take okay, let's say I just simply take one from here. Okay, so let's say I just take an example. Okay, say we have z equals to 2 plus 3j. Okay, so this is a complex numbers in the Cartesian form. Okay, how we write it in the exponential form? Okay, so when we look at here, okay, for this this Cartesian form that we have right now, right, we identify which one is the x, which one is the y. Okay, then when you look at the z, the exponential form, the r is actually square root of x squared plus y squared. So that means you need to calculate the x squared plus y squared, which is 2 squared plus 3 squared. Okay, so if you calculate 2 squared plus 3 squared, square root of 13. Okay, then for the theta, theta supposed to be arctangent of y over x. Okay, so your y is actually 3, your x is actually 2. Okay, so since this is both a positive value, x positive, y positive, so it is in the first quadrant. Okay, first quadrant, so arctangent of 3 over 2. Okay, so suppose if you press your calculator, you get 56.31 degree. If you calculate using your calculator. Okay, but since now your theta is in radian, so what you need to do is for your calculator, you change the mode to radian. Okay, for your calculator, you change the mode to radian. So when you change the mode of your calculator to radian, it's actually giving you 0.983. So which is in radian. Okay, 0.983 in radian. Okay, so get it? Okay, so that means you don't need to, since the theta of the exponential form must be in radian, so you don't need to calculate the value in the degree. So you just change the mode in your calculator to radian. So you get 0.983 radian. Okay, 0.983 radian. So for this z equals to 2 plus 3j, you can write it as square root of 13, okay, E, then J 0.983. Okay, so R, E, J theta, the R is square root of 13, then E, J, then the theta is 0.983. Okay, so that's how you write it. And of course, we can also calculate the values of square root of 13. You can express as a decimal. So it will be 3.606. Then E power of 0.983J. You can also express in this way. Okay, so can you understand? Okay. So the only things you need to take note is the way to find R and theta actually is the same. So you just need to take note, this one must be radian. So you don't need to convert it manually. You just use your calculator, change the mode to radian. So when you find the arctangent, they just return the value in the radian for you. Okay, is that clear? So I show you how to write the Cartesian form into exponential form first before we go further. So far, is that clear?
Yeah, clear, Miss.
Clear, okay. Then now, okay, so if clear, then I want you to do something, okay. Okay, so now I want you to try convert this to exponential form. Okay, so I give you z equals to 4 minus 2j. Okay, let's convert it into exponential form now. So write it in the R, E, J theta. Okay, let's do it now. I give you a few minutes. Once you got it, you can put it in the chat box. Okay, Samuel got his answer. Okay, how about others? Do you get the same answer as well? So we wait for a few more answers.
Excuse me, Miss.
Yes.
How to change the mode in the calculator to radian?
Is it your calculator also 570?
Yes.
Yes, okay, so on the top of the calculator there's a mode.
Yeah, the mode, yeah.
Okay, you press the mode once, then twice, then third time, fourth time. Okay, when you press the mode for 4 times, you will see DEG, RAD, GRA. Do you see it?
Just wait a minute, Miss.
You just 4 times.
Okay.
Then you see DEG, RAD, GRA, correct or not?
No, Miss.
No. Okay.
I see I can see like from 1 to 8.
Okay. I'm not sure whether your calculator is different with mine. Okay, so I'm not, okay, because when you press 4 times, then you will see, in your calculator, you will see D, E, G, R, A, D, G, R, A. 1, 2, 3. So this one is normally we choose so that our answer is in degree. Okay, so this one is in radian. You're
Okay,
supposed
miss.
to pick.
I can find it now.
Okay. So you press 2. So when you press 2, right, the top of the calculator, it will showing a capital R.
Yes.
That means your calculator already changed to radian.
Okay, miss.
You can try to calculate the one that we have earlier. So see whether you can get 0.983. Okay?
Miss. Okay.
Yeah. Okay, for the rest of the students, please take note, okay? When deal with this one, sometimes you need to change the mode. Have to be very careful. So because here we need to use using calculator is much more easier, okay? So else you have to do it manually, okay? So we do have a formula. Last time we already learned how to change the degree to radian, okay? There's a formula. But of course, since this one, if you're using calculator, then it's much more easier, okay? Yeah, so what is mentioned by Samuel is correct. Okay, so if we want to change the degree, 56.31 degree to the radian, right? We need to divide it by 180, then multiply by pi. So then you will get 0.983. Okay, so it's correct. Okay, now how about others? Okay, so I can see other answer from students. Looks a bit different. Saad answers for the imaginary part. Okay, so now let's check it out. Okay, so when we look at here, right? So this is a x. So the y is actually -2. So please take note. Okay, then when we calculate r, right? Okay, it's not affected by the sign. So 4 square plus -2 square is a square root of 20. So square root of 20 is actually 4.472. Okay, then come to the theta. Okay, so theta is arctangent of okay, y over x, right? So if I take the angle, okay, so that means 2 over 4 okay, hold on. So this one, x positive, y negative. X positive, y negative, which quadrant? Should be 4th quadrant, yes. Should be 4th quadrant, so
Miss is -2.
yeah, I know. I'm calculating the basic angle. Hold on. Let
Okay.
me confirm first. Okay, so if you're using negative, okay, can using negative, hold on. If I'm using, okay, so if you're using the negative here, you will express your answer in the negative radian. Okay. Wait, so let me confirm one more thing. Hold on. So because I want to see the calculator. Okay. Okay, so I think when come to this case, right, you also have to be careful. Okay, so because if you put in the negative sign, they give you negative radian, and this time it so happened that it is the correct answer. Okay, so let's say just now you put in negative, okay, it's still a correct answer. Okay, and if you not so sure, then if you want to confirm, you can actually change to degree, then from degree change to radian. Okay, so it's actually quite depends. Okay, so because for this case you get a fourth quadrant. Okay, so if you plug in the negative value just now, it so happened that the values you calculate is still correct. Okay, so if let's say this is in the second quadrant, then your answer is wrong. Okay, then your answer is wrong. So you have to be careful. Okay, you have to be careful. Okay, so if I'm, okay, I was showing you two ways here. Okay, so if you using the, it actually depends. How is which quadrant you are. So this one is actually 26.57 degree. So in the radian is 0.464, okay, radian. So if let's say in the fourth quadrant, okay, so if I want to calculate in positive angle, fourth quadrant, so fourth quadrant, the theta should be 360 minus 26.57. Okay, 360 minus 26.57. Okay, so 333.43. Okay, 333.43. So reflect the angle in the fourth quadrant. Okay, reflect the angle in fourth quadrant. Okay, so if you convert this to radian, you get 5.819 radian. Okay, 5.819 radian. Okay, so if I write it as a positive and radian, it will be 4.472 E J 5.819. Okay, so if you write it as a negative radian, okay, negative radian, then your answer will be 4.472 E negative 0.464 J. Okay, so if you write as a negative, okay, please take note. If you write it as a negative.
Which one is better? Is it better to write in negative or is it okay to write in positive?
Okay, so for this case, there is no, when come to the explanation form, there's nothing saying that a principal value to follow. As long as your theta must be radian. As long as your theta must be radian. So this is what we have right now. The basic angle is actually 26.57. It's actually in the fourth quadrant. Okay, so far I don't see any principal value they need to follow for this. So both is actually correct. Okay, if you put it in the positive, it will be 5.819J. If you put it in the negative, it will be negative 0.464J. Okay, so it's actually both is also correct. It's not wrong. Okay, but I don't encourage you to put in the sign. Okay, so in case you, because when come to tangent that is negative, right? Okay, which quadrant is tangent negative? So it's in the second and fourth quadrant, tangent is negative. Okay, so just now when you press the calculator, they give you negative radian, which is the fourth quadrant. But in case if you have the answer in the second quadrant, then when you plug in the negative sign, right, it doesn't reflect the correct answer. Okay, so can you see what is a possibility that you will get the negative value? Okay, so if I give you z equals to -4 plus 2j, so this is x, this is y. Then for this case, right, this is second quadrant. Okay, this is second quadrant. If you're using the way you put just now, you put in the negative sign, okay, then your answers is actually giving you in the fourth quadrant. But actually, this case, right, is actually in the second quadrant. Okay, so if you want it to be safe, so I think you don't put in the negative sign. Maybe you just write your answer in the positive in the degree. Then you manage with the degree. Okay, whether in the second quadrant or which quadrant. Then after that, you just convert to radian. Okay, so this is another suggestion. Okay, so sometimes you will, if you plug in the sign, sometimes you get it right, sometimes you don't get it right. Because calculator just give you one answer. They don't give you another possible answer. So do you get what I'm trying to tell you? Your calculator give you the answer in the fourth quadrant, but when the arctangent negative value can be in the second quadrant as well, then your calculator don't give you the answer in second quadrant. Do you get what I'm trying to tell you? Any doubt you want to clarify here? Any question? Else I will proceed. It's quite troublesome, to be frank, sometimes, okay? Okay, so Okay, no students say anything, so I will.
Hi, Miss.
Yes, yes.
So it's basically depends on the question that asks you lah. The answer either they ask you to put positive, then you put positive. It asks you to put negative, then you put negative, right?
Okay, so for this case, as I say, both answer also acceptable. Okay, and normally there is normally question won't say positive or negative for the explanation form, but but definitely the theta must be radian. If let's say not radian, then it will be wrong. Okay, so but so far we don't say it should be positive or negative. It doesn't matter. Okay, but I'm more concerned is how you actually find your radian. Okay, how you actually find your radian. If you put your negative sign just now, okay, from the beginning, this time it so happened that you get the correct answer. Okay, so because it so happened that they give you the answers, when you put the negative sign, they give you the answer in the fourth quadrant, and this is actually fourth quadrant. X is positive, Y is negative is fourth quadrant. Okay, but for if let's say your X is negative, Y is positive, right? When you find the arctangent, if you put in the negative sign, you still have negative values for the arctangent. Okay, then it's actually giving you negative 0.464 radian, right? Okay, so this does not reflect to second quadrant, then this one will be wrong. Okay, this one will be wrong. Okay. So as I say, if let's say you put in the negative sign, sometimes you get it wrong answer. So I'm not encouraged that, okay? I'm not encouraged you to put the negative sign here. So because sometimes you will get it wrong. Okay, now I look at the comment from Samuel. Okay, so we can only put in negative sign when changing back to Cartesian form. Yes. Okay, so because when you change to Cartesian form, you are using the cos and also sine. So this one not an issue. Okay, no issue on the sine. So I think the problem is always come when you find the theta, when you find the argument. So this one you should always calculate in the basic angle. The rest no issue. The only issue is with the argument theta, arctangent y over x. Okay, always don't put in the sign, but calculate the basic angle. Okay, deal with the basic angle using the basic angle. Find the degree or radian of the second, third, fourth, or quadrant. Okay, then after that, you only convert to radian. That way must be 100% correct. Then your answer must be 100% correct. Okay. Okay. Any question?
Okay, Miss. Understood.
Okay, then I will move on to, okay, yeah. Okay, just now is how we write our Cartesian form into the exponential form. So now we are going to go through on how we write the exponential form into rectangular form. Okay, so when you look at this example, right? Okay, so convert 7.2 EJ 1.5 into rectangular form. Okay, so now let's identify which one is the R. So the R is 7.2. Then your theta is 1.5. And remember, this is in radian. Okay, so now, okay, since you managed to identify which one is R, which one is theta, then you can easily write your answer in the rectangular form, okay? Because you can just write it as r cos theta plus r sine theta j. Okay, you just always using this formula to actually find the Cartesian form. Okay, to find the Cartesian form. Okay, so in other words, you can put it in the polar form first. Okay, so because the polar form is r angle theta, so that means from here we know that the r is 7.2, the theta is actually 1.5. Okay, but you have to take note, this is a radian. Okay, this is a radian. Okay, so you have to put 1.5 radian, else we may thought that is a degree. Okay, so then after that you can using this radian and find the r cos theta, r sine theta. Okay, so here will be 7.2 cos 1.5, 7.2 sine 1.5. Okay, so you write this in radian. So when you calculate in your calculator, you have to remember to change your degree to radian. Okay, change your degree. If your calculator is in the degree, you have to remember to change it to radian. So you can directly calculate. You don't need to convert to degree, because when you convert to degree is another hassle, okay, another work, right? So you can just convert your calculator to change the mode to radian and calculate the sine and cos. So you will get the answer. Get it? You can, guys, you can try to calculate. So I think your calculator is in the, yeah, if let's say it's not in the radian, you change it to radian. And after you change it to radian, then you try to calculate whether you can get 0.509 and also 7.182. You can try it now. Can you get the answer?
I got it, Miss.
Got it, huh? Okay. So for others, is that okay? Okay,
Yeah, miss,
then.
I also got it.
I got the same, miss.
Okay, good. Okay, then let's move on to the next one. Okay. Okay, so this one I put it in the Jamboard. Okay, you all can try to calculate. Okay, next one. Next one, you need to express this in Cartesian form. Okay, so suppose the way to do it is similar, but something's different with what we have earlier. So normally our z is in the form of r, e, j, theta, right? But what happened here, you have, you don't have j theta, but you have 1 plus. Okay, so then what should you do first? Okay, so z equals to 2e power of 1 plus j pi over 3. Then you need to rewrite it as 2 times e power of 1 times e power of j pi over 3. Okay, so remember, this is the exponential rules, right? If you have x power of 5 times x power of 2, okay, multiply. Okay, hold on, I'm using other notation. Okay, if I have a power of 5 times a power of 2, when the base is the same, it is actually a power of 5 plus 2. Okay, 5 plus 2. So now you have a plus, right? So that means I can write it as e power 1 times e power of j pi over 3. Okay, so now this one is your r. Then this one is your theta. Okay, so you have to be careful. Okay, so if I rewrite it, I have 2e power 1 times e power of j pi over 3. Okay, so when this is a r, I can write it as 2e angle pi over 3. Okay, your polar form, which is r angle theta, right? Okay, so r is 2e, theta is actually pi over 3. Then you already identify which one is r, which one is theta. Then you can find r cos theta plus r sine theta j, right? Okay, so that means 2e cos pi over 3 plus 2e sine pi over 3. Okay, let's calculate the values for 2e. Okay, again, your make sure your calculator is in the radian. So because you have pi over 3 radian. So calculate 2e. What do you get for 2e?
Miss, you just want 2e or you want 2e times cos pi over 3?
Oh, sorry. 2e times cos pi over 3.
Uh, 2.718.
Okay, correct. Okay, correct. Then you proceed to find for the imaginary part.
4.708.
4.708. Okay. Okay, so when you calculate for 2e, you have to be careful using your calculator. Okay. So when we have 2e, right, that means we take 2 multiply with e power 1. Okay. For your calculator, if you just press E, two times exponential. If you just take 2 times E, I think they give you syntax error. Okay, so you have to put it as a e power of 1.
That means my calculator is okay though. Can work.
But if you calculate e only, I think can. But if you take 2 times e, then cannot. My calculator cannot, so I'm not sure about yours calculator. Okay, so that's why everybody should try. Okay, and see whether you can get this answer.
Mine works, miss.
Okay, Ilalam say his calculator cannot. Okay, then Ilalam, you try to calculate 2 multiply E, then followed by 1. Okay, so when you take supposed to get 5.43656. Okay, so you need to figure out how to actually calculate. So my calculator sometimes cannot. My calculator, after press the explanation, must follow by 1. Else it will give you maths error. Then I times 2, I get 5.43. Okay, so Ilalam, if you press the explanation followed by 1, then you multiply, then for the answers you get, you multiply by 2. Can you get the answer? For those cannot, okay, then press the exponential followed by 1. Then multiply, get the answer, then multiply by 2. So those cannot, please try it out until you get the correct answer. So Ilalam, how about now? Can you get it? Because we have to ensure that we calculate it right. So else when come to the exam time, the working is correct, but when we calculate, we get the wrong answer.
Miss, I can't find the E. Is
You-
it like E like the pi?
No, E is not the pi. E is an exponential. So your calculator, okay, above the button for ln, there is a E power of x. So that's why you need to try, can you get this answer or not? Yes, you have to press shift. Shift, then shift ln. This is natural logarithm.
Yes, Miss, I got it now.
You got it now, huh? Okay.
Okay. Thank you, Saad.
Hmm. Okay. Okay, okay, make sure you get the correct answer. So the value as your reference, because sometimes you got it, but may not be the correct answer. Okay, so this one, done. Okay, then next. Okay, so 3:30 already, I give you a short break, okay? Then after that, we will come back to how we deal with the multiplication and division for the number in the polar form, for the number in the polar form. Okay, so 10 minutes break. Okay, so see you after 10 minutes. Okay, students, let's continue. Let me take the attendance first. Okay, today is T3, sorry, T4. Okay, take your attendance. Two more students. Junho. Okay, 14 students are here already. Kwa Junho. Sutej.
Yes, miss.
Okay.
Yeah.
Junho. Kwa Junho. Okay. Okay, so all present. Very good. Let's continue. Okay, so already go through from the explanation form. So the next part is how we deal with the multiplication and division for the polar form. Okay, so previously we have done how to do addition, subtraction, multiplication, and division for Cartesian form. Okay, Cartesian form, which is for division involve the complex conjugate, right? Okay, but when come to polar form, okay, so we haven't go through on how to deal with the multiplication and division, right? Multiplication and division. Okay, so now let's look at this, okay? Okay, so how we actually do the multiplication and division for the complex numbers in the polar form, right? So this is in the polar form. So let's say you have Z1 and Z2, both in the polar form. So if you want to multiply the two complex numbers, then we will multiply the R1 and R2. Okay, we'll multiply the R1 and R2 from each complex numbers. And then what happened to the theta, the argument? So you will taking the sum. Okay, you will taking the sum of the theta and also theta 1 and theta 2 from the first and second complex numbers. Okay, so when come to division, then the R1 and R2 from each complex numbers will also have a division. Then when come to the angle, the theta, it will be a subtraction. Okay, if Z1 divided by Z2, then will be theta 1 minus theta 2. Okay, so please take note about this. Okay. Okay, so this is how we deal with the multiplication and division when the numbers in polar form. Okay, so now let's look at this one. Okay, so if we have a 8 angle 25 degree. Okay, so multiply with 4 angle 60 degree. So when we involve multiplication, that means for the R that we have, right, 8 and 4, we need to multiply them. Okay, then for the angle that we have, okay, 25 and 60, we're taking their sum. Okay, so this is very simple, right? So that means we get 32, the R will be 32 angle 85. Okay, so next one, you can also multiply more than 2 complex numbers here. Okay, so when we refer to the this multiplication, okay, for the R that we have, right, we are going to multiply them. Okay, 3 times 5 times 2. Okay, then for the angle that you have, right, so this is your angle, the theta, then you were taking the sum of the theta. So according to the rules just now, okay, you're just taking the sum of the theta. So our answers is actually 30 for R, then the theta is 52. Okay, so I think this is easy to understand. So is that clear? The multiplication?
Yes, miss.
Okay, so next one is the division. Okay, when come to the division, okay, so for the R, we will divide. Okay, so 16 divided by 2, we get 8. Okay, so that means our step is 16 divided by 2. Then for the angle, remember the top is 75, the bottom is 15, so it's a subtraction. Okay, so when come to the theta, we will do the subtraction. So we get 60. Okay, so please take note. Okay, next one. So for the next one, right, okay, let's say we deal with the one at the top. So when we deal with the one at the top, so can you see the R is 10 and 12? So 10 times 12. Then for the theta, okay, since it's involved multiplication, then we'll be taking the sum. Okay, then next, okay, at the top you have 120 angle pi over 4 plus pi over 2. 3 over 4 pi, that is the top. Okay, then what is the next? Come to the division. So 120 divided by 6. Then for the angle will be, the top is 3 over 4 pi, right? Then minus, because of the division, minus the angle at the bottom, which is negative pi over 3. Okay, so become a plus. 3 over 4 plus 1 over 3. Okay, so 120 divided by 6 is 20. Then 3 over 4 plus 1 over 3. So we get 13 over 12 pi. Okay, 13 over 12 pi. Okay, so now since you need to put it in the polar form, okay, so when come to polar form, remember normally is in theta, in degree, right? In degree. So this one you need to change to degree. Okay, so when we changing this to degree, 13 over 12 pi, so you should take 13 divided by 12 times 180. Okay, so that means 13 over 12 pi, you need to multiply by 180. Okay. Then you get 195. Okay, 195 degree. Okay, clear? Okay, that's how we get 195. Okay, so is that clear?
Yes, miss.
Okay, so next one. Okay, just already go through. Okay, there is a rules we can apply on the polar form when we want to deal with the multiplication and division, okay? But what happens if we want to deal with addition and subtraction, okay? Unfortunately, there's no rules we can apply when we deal with the addition or subtraction in the polar form, okay? So what we need to do, okay? So we can't just directly deal with that, okay, when they are in the polar form. So what we need to do is we need to convert it back to Cartesian form for each of them, okay? Okay, so maybe after you hear that, you want to faint already. So that means for this case, right, we have 3 complex numbers in polar form. Then for each one, we need to convert it into Cartesian form, okay? Convert it into Cartesian form, then we just conduct the addition subtraction into Cartesian form. Then after that, we convert it back to polar form if you are required the final answer to be in the polar form. No choice. Okay. So now for the first one, for 2 angle 30 degrees, so this is r, this is theta. So we just applied this one, r cos theta plus r sine theta. Okay, we always using this one to put in the Cartesian form. Okay, so that means 2 cos 30 plus j2 sine 30, and you get 1.732, okay, plus 1j. Okay, then after that, okay, come to the second complex numbers, 5 angle negative 45 degree. So you just directly plug into the formula. So which is calculating 5 cos negative 45 degree, 5 sine negative 45. So you get 3.536 minus j 3.536. Okay, so you just calculate in the Cartesian form. Then for the next one, 4 angle 120 also the same. Okay, you just plug into the formula. So 4 cos 120 plus j4 sine 120. Okay, just substitute into the formula, then you get the answer into the Cartesian form. Okay, then after that, okay, so you want to take the addition for the first 2 complex numbers and subtraction, right? Okay, so remember when we deal with addition and subtraction into Cartesian form, we need to do it separately for the real part and also for the imaginary part, okay? The real part and the imaginary part. So for the real part, we have 1.732, 3.536, and this one, negative 2. Okay, so we take the sum 1.732, okay, plus 1.732 plus 3.536, then minus negative 2. Okay, so that means for this part, we are going to calculate the real part as 1.732 plus 3.536, then minus negative 2. Okay, this is a real part. Okay, then for the imaginary part, okay, then 1 plus negative 3.536, then minus 3.64, 464 J. Okay, so this is the imaginary part. Okay, plus and addition and subtraction. Okay, then you calculate for the value. So 1.732 plus 3.536 plus 2. So you get 7.268. Okay, we get this answer when we calculating this part. Okay, then next one, for the imaginary part, 1 minus 3.536 minus 3.464. So you got a -6, correct? -6, huh? Okay, so this is the answers in the Cartesian form. But the question just now required your final answer in the polar form. Then you need to convert it into polar form. Okay, so remember we need to calculate the R. So this one is your X, this one is your Y. Huh? So your Y is -6. So R equals to square root of 7.268 square plus -6 square. Okay, then your answer will be then you have to find the square root 9.425. Okay, 9.425. Okay, then after that the arctangent. Okay, remember I always don't put the sign. Okay, I calculate the basic angle. So arctangent will be 6 over 7.268. Okay, and I get the basic angle. Okay, and remember to change it to degree, else you will get the answer in radian. 39.54 degree. 39.54 degree. Okay, then can you see we have x positive, y negative. Okay, x positive, y negative, which is in the 4th quadrant. So that means this is 39.54. Okay, so it's in the 4th quadrant. So when in the 4th quadrant, we can calculate it as a negative angle. So I can write it as negative 39.54. Just calculate as a negative, write it as a negative angle. Okay, so is that okay so far? So as a conclusion for polar form, if you deal with multiplication and division, you can using the rules, these rules. But if you deal with the addition, subtraction, no choice, you must convert it into Cartesian form. Then simplify, okay, conduct the addition, subtraction in the Cartesian form. Then if let's say at the end you need the answer in the polar form, then you convert back to polar form. Okay, clear? Okay, so next part is at the end, we already done all the 3 forms of the complex numbers. Okay, so that means Cartesian form, polar form, and also exponential form. Okay, so please take note on this. So this is Cartesian or rectangular, write as a plus jb, or you should understand that it's actually a plus jy as well. Okay, then when we write as r bracket cos theta plus j sine theta, or this is an abbreviation of the polar form, r angle theta, so this is polar form. Okay, so the last is an exponential form, r e j theta, and please take note, the theta here is actually in radian. Okay, the theta in radian. And for polar form, the theta, we always apply the principal value, negative pi to pi. Okay. Okay, next one. Next one is a de Moivre's theorem. Okay, what is a de Moivre's theorem? So de Moivre's theorem will be useful if we want to calculate the, evaluate the power of the complex numbers. The power of the complex numbers. Okay, so just now we already go through, right? Okay, when it comes to multiplication of the complex numbers, we can apply the rule. So when we want to multiply, what happened to our r? So we will take r times r. So if let's say it's the same complex numbers, r times r essentially give you r squared. Then what happened to the theta? So the theta is actually theta plus theta. For multiplication, we add it up. So when you have theta plus theta become 2 theta. Okay, if we apply this to the, if we multiply this for 3 complex numbers, the complex numbers that are the same, right? 3 same complex numbers, then you are getting something similar. That means for the r, you need to multiply the r for 3 times. That means you get the r cubed. Then for the theta, you have to add 3 times. So you get 3 multiply theta. Okay, so from the power of 2 and the power of 3, okay, so we found that we can actually summarize r, the polar form with the power of n by r power of n, then n times theta. Okay, n times theta. So as you can see right here, okay, so when we have here is power of 2, so this one 2 theta. So when here is power of 3, so this one 3 theta. Okay, you can see. Okay, so this is a de Moivre's theorem. So it's going to be very useful if you deal with the power. So for example, power of 5, power of 6, when you have higher values of the power, so of course it's impractical for you to actually expand it as a normal way. That will be difficult. Okay, so now let's look at a few examples here. By using the de Moivre's theorem is become much more easier. But one thing, when you want to apply de Moivre's theorem, right? Okay, your complex numbers must be in the polar form. Because when you look at here, your complex numbers is in the polar form. Okay? Okay, now, so let's look at this example. Okay, 3 angle 20 degree, power of 4. So for the r of the 3, you're going to take the power of 4. And then for the power of 4, right, 4 have to multiply by the 20 degree. So 3 power of 4 is 81. Then the angle will be 80. Okay? After we applied the de Moivre's theorem. So it's very easy, right? Okay? So now let's look at the first questions here. Okay, so for the first question here, this one is already in the polar form. So if you want to calculate the power of 5, then will be very easy. So for the r, which is our 2, you calculate as 2 power of 5. Then for the 35 degree, you need to multiply by 5. This is de Moivre's theorem. Okay, so if the numbers are already in the polar form, then will be very easy. So this one, if I write as the answer, 2 power of 5 is 32. 5 times 35 is 175. Okay, so this is the answer. Okay, next one. Next one, okay, another question here is the power of 6 for the complex number in the Cartesian form. Okay, so when come to Cartesian form, of course, it's not easy for you to expand to the power of 6. Then you can actually solve this using the de Moivre's theorem. But in order to solve this by using the de Moivre's theorem, for the complex numbers that you have in the Cartesian form, no choice, you must convert it into polar form. Okay, you have to convert it into polar form. You can see the first step here, we are converting it to the polar form. So by calculating the r, right? So the x is -2, the y is 3. Okay, so we have to calculate. Okay, hold on. Okay, so here we calculating x squared plus y squared for the r. Then for the arctangent, okay. So for the arctangent, then will be y over x, right? As I say, my practice, I don't put the sign. Okay, So the y is actually 3, the x is actually 2. Okay, so arctangent of 3 over 2, if you get the basic angle, will be 56.31 degree. Okay, 56.31 degree. Okay, this is a basic angle. Okay, so since your x is negative, y is positive, x negative, y positive will be in which quadrant? Second quadrant. Okay, second quadrant. So that means you should take 180 degree minus 56.31. So you get 123.69. Okay, 123.69. Okay, so that's how we get 123.69. Okay, so guys, can you see now, right? Okay, if you put in the negative sign, you will realize that when you calculate the when you press your calculator, you won't get 123.69. You will get 123.69 if you calculate the basic angle, then identify it is in the second quadrant, then you get 123.69. If you already put in the negative sign and you press your calculator, you will not get 123.69. So please take note. So that's why to me, I don't actually like to put in the sign. Okay? Okay, so if I'm showing you this way, right, you will get confused. So that's why I never put in the negative sign. Okay, now, so this is in the second quadrant. Okay, so you already have your answer in the polar form. Okay, write it in the polar form. Then you just calculate the power of 6. So for the r, you just take a power of 6. And then for the angle, you just multiply by 6. Okay, so for r power of 6, right, you get 2197. Then for the theta, right, 6 times 123.69, you get this answer. Okay, you get this answer, right? Okay, so however, okay, can you see when come to the fourth quadrant, right? Okay. So for one cycle, we have 360 degree. So if let's say 2, then will be 720. Right? So this one is already exceed 2 cycles. Okay, exceed 2 cycles. So we will try to express our answer within 0 to 360 degree, right? Okay. So, 180, or principal value will be 180 to 180. Okay. So now, so what you can do is you minus 720, because we know that 742 is already more than 2 cycles. So you minus 720, okay, you get 22.14. Okay, you get 22.14. Okay, so which is in the first quadrant, right? Okay.
So Miss, you can just straight up just minus 720 lah. You don't have to write
yes.
minus 360 twice now.
Yeah, yeah. If you understand, you just directly minus 720. Because some if they're not sure, they minus 360. If still exceed 360, then minus 360 again until you get the value which is within 0 to 360. Okay? Okay. So this is our answer. Okay? Okay, next one. So this is regarding the Moivre's theorem again. Okay, let me see. Okay, we almost finished already. Okay, so the rest is an application. Okay, now for the next one, okay, So determine the value of -5 plus j5 power of 4. This one requires power of 4, and you require in polar and rectangular form. Polar form and rectangular form. Okay, so okay, remember, since this is power of 4, if we want to using De Moivre's theorem to evaluate it, then we have to write it into polar form. You need to convert it into polar form. So calculate the okay, so your x is -7, y is 5. So calculating square root of x squared plus y squared. Okay, you square the -7, you square the 5, you add it up, so you get square root of 74. And then come to the angle. Okay, so as I say, I don't put in the negative sign. Huh? So let's say I calculate arctangent 5/7. Okay, arctangent 5/7. So I get 35.54 degree. Okay, now when you look at the x is negative, y is positive, which quadrant, students? X negative, y positive, which quadrant?
Second quadrant.
Second quadrant. So for second quadrant, then how you going to calculate? Okay, then will be theta equals to 180 minus 35.54. So 144.46. Okay, 144.46. Okay, that's how you get 144.46. Okay, so next you need to calculate the power of 4. Okay, power of 4. Okay, so we must put in our complex number into the polar form. Power of 4. So that means square root of 74 power of 4. Then for the angle, 4 multiplied with 144.46. Okay, so this is what we get. Okay, then can you see for the theta here is already exceed 360. So we take 577.84 minus 360. Okay. So you get 217.84. Okay, you get 217.84. Okay, so this one you can remain this as an answer. Okay, so this one is in the polar form. Okay. Okay, here they didn't proceed further to put in the principal value. Okay, so they write it as this one. Okay, so what is the next? You also require the answer in the Cartesian form. Okay, Cartesian form. So remember, R is 5476, theta is 217.84. Okay, so you just calculate by R cos theta, J R sin theta. So R cos theta, which is 5476 cos 217.84, then R sin theta 5476 sin 217.84. Okay, then you calculate the value. Okay, it gives you negative sign. Okay, so negative sign. Okay, now when you look at both x and y are negative, real part is negative, imaginary part is negative. So when both negative, which is in the third quadrant, so our angle just now is actually in the third quadrant. Okay, so we have our answer in both the, how to say, in the polar form and also in the Cartesian form. Okay, so this is the De Moivre's theorem. Okay, how we apply it to evaluate the power. Okay. Okay, so we still have another 15 minutes. I just saw it whether I have a time to go through. Okay, so this last part is about applications of the complex number. Okay, application of the complex numbers. Okay. Okay, so this is the applications of the complex numbers that we apply into the impedance, reactance, resistance. Okay, we can also express the impedance into the complex numbers. Okay, impedance in the complex numbers. Okay, actually I have a few links, can be your reference regarding resistance, reactance, and so on. But I'm not sure, maybe this semester, I'm not sure whether you have gone through this in your engineering modules. I'm not sure, okay? So maybe you already have some basics ideas on this one. Okay, so I have some, this one is for your reference. Maybe I put it in the chat box. So for the quick recap on what is the, okay, try to paste it. Okay, hold on. Okay. So this is some definition of the terms regarding the impedance, resistance, and reactance. Okay. So for your recap, okay, and we can, as I mentioned just now, impedance, we can actually write it in the form of the complex numbers. And the impedance is a combination of the resistance and reactance. So the real part, we can actually, the real part is representing the resistance, and the imaginary part is a reactance. Okay, then what is a inductor, what is a capacitor, what is an inductive reactance, and so on? You can have a look here. Okay, and then this is some of the notes I get it from online. So I just take the important part. Okay, so I also have a link for some of the references here, or you can just go online and look for that. Okay, now or maybe this one I go through tomorrow, okay? So, but just now I try to put the terms for you in the chat box so you can have a look, okay? So that tomorrow before we come to this one, okay? Then you can understand better, okay? So I think this part I'm going to go through tomorrow. And another problem too is also regarding the application in engineering, okay? The applications of the complex numbers, okay, in the engineering, okay? Then for the tutorial question, previously we have done until question 7, okay? So for what I have taught today, you can continue from 8 until 12. Okay, 8 to 12 also quite a lot already. Huh? Okay, 8 to 12 also quite a lot. Okay, I think tomorrow I will continue the discussion of the tutorial. So after I discuss the tutorial, then I will only continue with the lecture. So if let's say tomorrow I can't able to complete, then I will use one more class. Okay, that means next week class to actually complete the application part. Okay, so you need to practice 8 to 12. Okay, questions 8 to 12 for the tutorial. Okay, so for the various complex numbers given, the form of the complex numbers given, you need to determine the value into the Cartesian form, and then this one in the exponential form, this one in the polar form. So you have to be careful whether they ask for exponential form, Cartesian form, or maybe polar form. So even though questions don't really look a lot, but there's a lot of calculation. And 11 required to use de Moivre's theorem. 12 also required to use de Moivre's theorem. But this one, when you apply de Moivre's theorem, final answer in polar form. This one, after applied the de Moivre's theorem, you have to simplify in the Cartesian form. So you have to be very careful, okay? But if you really understand how to do this, right, I think you will understand how to do the conversion. So this one, it will involve a lot of the conversion from polar form to Cartesian form to polar form, then to exponential form. Okay, so there's a lot of calculation for this part. I think tomorrow, maybe we will just spend the 2 hours time just for this 5 questions. Okay. Okay, so we have another 10 more minutes, okay, 9 more minutes. So a reminder, okay, sorry, a recap on what we have, a review on what we have learned today, okay. Okay, so a review on what we have go through today. Okay, so how we actually write our polar form into the Cartesian form. Okay, we always use the formula of the r cos theta, r sin theta, r cos theta, r sin theta. And for your information, when you want to write it in the Cartesian form, you just directly put in the angle, okay? Then let the calculator give you the negative or positive value, okay? Then will be easier. Okay, then for exponential form is in the form of Rej theta, Rej theta, where the r is a modulus square root of x squared plus y squared. Okay, so that means if your z is given as x plus yj, then this is how you calculate the r, and the theta must be in radian. Okay. Okay. Then how to convert to rectangular form? You can write in the polar form first, which is r angle theta. Then you just substitute into the formula r cos theta, r sin theta to get the answer in the rectangular form or Cartesian form. Okay, so when you have e power of something plus j theta, then you have to be very careful. Okay, so you need to apply the laws of indices. So which you have to write 2e, then multiply by e power of j pi over 3. Okay, so then this part will be r, then this part will be j theta. Okay, then you can write it into Cartesian form. Okay, so next one is how we deal with multiplication and division for complex numbers, which is in polar form. Okay, so for the r, we will, when come to multiplication, for the r, we will multiply, for the angle, we will taking the sum. So when we want to do the division, then for the r, we will do the division as well, but for the angle, we will do the subtraction. Okay, so please take note. Okay, so we can apply these rules to evaluate multiplication and division for the complex numbers into polar form. Okay, but as I say just now, if you need to do addition and subtraction, there's no rules you can use, okay, when your complex numbers into the polar form, but you need to convert each one of them to the Cartesian form, okay, and then if you want the final answer into polar form, then at the end you need to convert it back to polar form. Okay, so these are the 3 forms of the complex numbers that we have gone through. Okay, so this is the Moivre's theorem. So we use it for the calculation of the power. Okay, calculation of the power. Okay, so if let's say we have power of n, we just take the r multiply r power of n, and then for the n, right, multiply with theta. Okay, so please take note. Okay, so I think, yeah, that's what we do for our recap. Okay, so, right, okay, don't forget, okay, later 4:45, you should go to Moodle to actually, the link is accessible at 4:45, okay? So in case you have any issue to access to the link, please let me know, okay? Later 4:45, don't have a class. So I will see if no issue, then later 5:30, I will carry on with my class already. And please take note, you have 1.5 hours to answer, and then submit by 6:45, okay? And try to submit as early as possible. Don't submit as a last minute. And I require in PDF file. Remember, PDF file. Okay? And make sure you arrange your question according to question number. It will be easier for me to mark. Okay? So I think that's all for today. Okay, any questions you want to ask before I dismiss the class? Okay, because you can go to prepare for your class test 2 already. Okay, maybe you need to have a short break.
All clear, miss.
Okay, right? Okay, thank you for the feedback. Okay, then if let's say nothing, no question, then I will dismiss the class. So guys, good luck for your class test 2 later. Okay, so I will see you tomorrow again. Tomorrow we will go through the tutorial question. Okay, that's all for today. Bye, students. Good luck.
Okay, bye, Miss.
Bye.
Thank you.
Thank you, miss. Bye-bye.
Bye-bye. Welcome.
Thank you, miss.
Yeah,
Bye-bye.
bye.